recording. Okay. And pull up. Well, thought I had it pulled up. Evidently I don't. www.tctc.my. Oh, I know what happened. It didn't have the login when I pulled it up. I have to go through here. And nope. So we started on 7, I think it was 7A. Check my. I think we started on that, which is a lot of introduction to probability, talking about the complement and talking about. I hope I can turn this thing around. Let me just see, because I went over the introductory part, and I really don't know what type of thing the book is going into, so just bear with me for a second. Okay, there's the outcomes. We talked about outcomes. That's like tails, 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 heads, heads, tails, heads, heads, if you're flipping a coin. We talked about what an event is, finding the probabilities. We talked about from 0 to 1. Talked about that's what the probability is going to be between. Number of ways an event can occur over the number of possible outcomes. We talked about that. We talked about the theoretical probability versus the physical probability. One is observation, one is mathematical. I think they talk about that in the next section. Here's the multiplication principle. We're going to go into that today. And we're going to go into the additive principle. As soon as I get there. There it is. Theoretical probability is an assumption where equally likely. In other words, like the four face cards out of a 52 card deck. Relative frequency is based on what? Observations. I call that the physical probability versus the Mayberry probability or the theoretical probability. Probability of an event not occurring. That's the complement. And they should go into the complement on the next page. Or say something about a complement. Somewhere in here it'll say something about a complement. But that's what the complement is right here. So if you have an event, let's see if I can get this thing working. There we go. If you have an event happening, it's supposed to be on autofocus. I thought that's what it was on. No. Autofocus. There we go. If you have, let's say, what is the probability of a face card in a deck of cards? And you go with the theoretical probability of what? 4 out of what? 52. Then you would do the complement. Okay, why is that thing not? Okay, it's going back and forth. Then the probability of, what's the opposite of a face card? Well, a F with a what? An X through it. Now some people do this, some teachers do this. Some people put a little mark above. Well, there's Zach. Hey Zach, glad you could join us this morning. Some people put a line over the F to say not F. Okay, so you may see it one of two different ways. So what would be the complement of 4 out of 52? That's not rhetorical, I'm asking y'all. Huh? 48 out of 52. Now, something you're going to see with odds, and we're going to go into odds probably in the next today, odds against and odds in favor. I'll just go ahead and say that. Odds against is equal to the probability of failure over the probability of success. Odds in favor is the probability of success over the probability of failure. Now, how are you going to know which one is success and which one is failure? Well, the question will say, you want to win a card game in Vegas, and the way that you win is to pull a face card. I'm sorry, that's supposed to be a king. Sorry. I did that yesterday in 120. I don't know why I'm doing that. All right. To win, you have to pull a king out of a deck of cards. All right. So success in this question would be what? Pulling a what? A king out of a deck of cards. That would be success. So the failure would be what? Not a king. Okay? And that's how you determine what's a failure and what's success. So the failure and success will be given in the question. Okay? Failure or success will be given in the question. All right? For instance, there's a question that I use all the time in probability about this, and it's called the roulette wheel. And the roulette wheel basically says you have a roulette wheel, and a roulette wheel is that black and red roulette wheel that spins in Vegas. And you have 40 slots numbered 1 through 40 with 2 slots with 0 and 00 that are not odd or even. And the question asks, what is the probability of the marble showing up on an even number? All right, that's A. And then B, it's going to ask you, what are the odds against? And that's what they use in Vegas. What are the odds against pulling an even card, or what I meant, a number? And then the last question says, what if you bet $500, on this game, what would you take home? Okay? So, the first thing you do is you got to find the probability of failure over the probability of success. You got to find those two things. So, winning is probability of an even number. So that's success. Because the question asks, what is your probability of getting an even number? So, probability of not an even number, either with a line over it or an X through it, is equal to the what? Failure. Okay, so the even numbers, divide 40 by 2, what do you get? So the probability of an even number is equal to 20 over 42. The probability of not an even number is equal to what? 22 over 42.
22?
Yep. How many slots are there? How many slots are there on the whole table? Huh?
42, ain't it?
42.
Oh. So
They
that's
1 through 40 are numbered 1 through 40.
Mm-hmm.
And then 2
Oh.
are 0 and double 0.
Gotcha.
Now, what's the 0 and double 0 for? Well, if you want to bet on 0 and double 0, you'll win more money because it's only 2 slots out of 42. So it's a way to win more money. Okay? So that's A. B. Odds against is equal to the probability of failure over the probability of success. And leave everything a fraction because it helps with the math. So, what's the probability of failure?
20 over 20.
22 over 42. And what's the probability of success? 20 over 42. Now, when you divide by a fraction, you multiply by the what? Multiply by the reciprocal, Hubert. That's right, class. So that would be 42 over what? 20. And look what happens to the 42s. That's why you leave them a fraction. So you can cancel them out. So the odds against is equal to 22 to 20 or 11 to what? 10.
And that's for B.
That's for B. And you can write it like this, 11 over 10, if you wanted to. Now, before I go to the C section, before I go to the C part, I want to go back and do something that you probably did in basic math. Okay, let's say that you have a recipe, and that recipe makes 2 dozen cookies. No yawning in class. 2 dozen cookies. And that's 1 cup of milk, a third cup of butter, 2 cups of sugar, 1 cup of flour, and I did a cup of milk, butter, sugar, flour, vanilla, 1 teaspoon of vanilla, and that's your recipe. Okay. What if I ask you to make 48 cookies? Okay, 2 dozen is 24. So take 48 and divide it by 24. What do you get?
2.
So I double all my ingredients. So that'd be 2 cups of milk, 2/3 of a cup of butter, 4 cups of sugar, 2 cups of flour, and 2 teaspoons of vanilla. So what if I asked you to make, I don't know, 70 or 75 cookies? You take 75 and you divide it by 24. Take 75 and divide it by 24. What do you get?
3.125.
3. That'd be 3. What would that be? 72. That'd be 3 over 24, which is 1 over 8. 3 and 1/8. Or, what'd you say?
3.12.
3.125. And you multiply that by each one of your, so a little bit over 3 cups of 3.1 cups of milk. And then 3, there's going to be a 1.1 cups of butter. 3 times 2 is 6.2 cups of sugar. And 3.1 cups of flour. And 3.1 teaspoons of vanilla. So whatever your constant is, that's what you multiply by, right? Do y'all agree with that? Okay, let's go back here. What is your constant? 11 tenths. Or 1.1. Whatever you want to call it. So what are you going to do with that 500? You're going to multiply it by what? 11 tenths or 1.1. Do that with your calculator. What do you get? Well, 10% of 500 is 50, so it'd be 550. So what do you take home? $550. If you pull a even card or even number, if the marble falls on 2, 4, 6, 8, 10, 12, all the way up to 40, if it falls on an even number, you get $550. Well, why in the heck is that so low? Why you only win $550? You only won $50. How can you get rich doing that?
You can't.
Can't. Why?
They made it that way.
They make it that way because the probability is high that you're going to fall on a what? On an even number. Your probability is 20 over 42. What is 20 over 42 on your calculator?
.4762.
0.47. That's almost 0.5. You think, is Las Vegas in the charity business? No. There's 2 entities in life that are not in the charity business. What are they? The bank and Vegas. Okay? They are not in the charity business. They will try to take as much money from you as they can. Huh? They are. You know, my dad always says there's 2 kinds of people in the world. There's givers and there's takers. Banks and Vegas are takers, and they do not hee-haw around it. They do not care what you think of them. They are takers. So, if the probability of you winning is high, then the odds against are going to be what? Low. Because they're not in the charity business. All right? I want you to find out what you would take home if you bet on the 0 and 00. Do that. That means you have to work. That means you have to start writing. What is the take home if you bet on the 0 and the 00? In other words, you put down money on 0 and 00. You put 500 on 0 and you put 500 on 00. What do you win? Give y'all a minute to work that out, because you got to go through and do success, failure, odds against, and then multiply it by $500. So, what is the chance of you winning with 0 and double 0? Well, how many slots are there? 2. There's 2, right? So that'd be 2 out of what? Probability of success? Probability of 0 / double 0 is 2 out of what? 42. Therefore, the probability of failure, 0 / double 0 with a X through it, is equal to what? 40 over 42. So that's A. B, what is the odds against? So I'll put odds, and then I'm going to put a little A right here for against. Is equal to what? 40 over 42 divided by 2 over 42. Multiply by 42 over 2, and you get what?
20 to
40. There you go. Listen to this girl. She's a gambler. 20 to 1. Listen at her. She didn't say 20. She said 20 to 1.
I wish
So we all know who's a gambler in the group. 20 to 1. So let's say that Zach or Miss Smith go to the Cherokee Casino and they throw down $500 on 0 or double 0. Then they're going to take home, and if they hit, what are they going to take home? $10,000. Whoa, wait a minute. Well, that sucked. I bet on even and only won $50. Why? What's the probability of winning with 0 and double 0? Somebody do 2 over 42. What do you get?
1 over 21.
1 over 21 decimal.
0.0476.
0.4. 4%. You got a 4% chance of what? Winning. What did you have with the even number?
0.5.
You had a 50% chance. So, let's write down something that will help you in real life. If probability is high, the payoff is what?
Low.
Is low. If the probability is low, the payoff is what?
High.
Nothing is what?
Free.
Nothing is free. Okay? There is some penalty somewhere. Okay? You don't go into a casino and win a bunch of money without some catch. Alright? And that catch is you could lose it all at what? Anytime.
Yeah.
Anytime.
I want to quit. Yeah, you gotta know when to quit.
Yeah.
Not too long ago.
Well, when I was stationed in 29 Palms, I was stationed out there for about 6 months doing a CAX out in the desert. And we decided they wouldn't rent us a car. Okay, there was 6 of us that we had like a 48-hour R&R, and they wouldn't rent us a car because they didn't rent Marines cars. So we rented a U-Haul box, a box van,
Yeah, I was shocked.
and we had a designated driver, and that box was plywood on the inside. We're talking about in the middle of the summer in the desert out that Joshua Tree, and we put a keg and a bottle of Jack Daniels in the back of that thing and our gear, and by the time we got to Vegas, we were dehydrated and about passed out, and we had to roll out of the thing. Make a long story short, we gave the driver each each of us gave him like $200 or $100.
Dang, I need the Uber. I need the Uber.
No, we gave him that for him to hold.
Oh.
Yeah, because we wanted to make sure we had money to get home.
Got you.
And we lost everything. And if it wasn't for him, never forget his name, Grover. You know, like Grover, the Muppet, Grover. His name was Grover. And he sat up in the room the whole time and played his piano. He had one of those electrical keyboards. And he was a good Marine. He just wasn't the what do you call, the stereotypical Marine. He was the opposite of the stereotypical Marine. Anyway, he kept our money, and when we checked out, he gave us all our money back, and we had money to get home. Anyway, you have to do that when you go to Vegas, because you may go to Vegas and have a good trip and win $5,000. And you may go to Vegas and not win. What's the likelihood? You're not going to win, okay? Nothing is free. You end up paying some way, somehow. Anybody got a comment on that one? Because that is a test question. Okay?
I have a.
Yes.
And I'm not trying to be hammy. This is the kind of thing that'll make me mess up.
That's all right.
Okay, so the question was a 0 or a double 0, not both. So
Yeah.
when I started doing the problem, I was doing it like two separate problems. So how do I know that it's 2 over 42 instead of 1 over 42?
Well, if it was just 0, it would be 1 over 42. Okay?
But does the odds not change to get, well, I guess it didn't say a 1 and a 0. I mean,
Yeah,
0 and
it didn't say 1 and. I said 1 or. And that's why, it's not going to change that much. 1 over 42 versus 2 over 42. The percentage is not going to change that much as far as and the whole purpose of me showing you this part of the question was not for the math. The purpose of me showing you the 0 or double 0 is this right here. That's the only reason. So don't look at the math that much on this, because I'm not going to ask you 0 or double 0 on the test. I'm going to ask you even or odd. Okay, I'm going to ask you this right here. That's what I'm going to ask you on the test, which is a whole lot easier to do.
Okay,
Does that answer your question?
I'll overthink it and talk myself out of knowing.
Yeah, don't do that. Just do even or odd. Okay?
Okay.
And if it was odd, would it be the same? Yes. Because how many odds are there in 1 to 40? 20.
20.
You just divide it by 2. Okay? Divide 40 by 2, and that's how many odd or even you have. Okay? The only reason I did this was to show, the only reason I did this was to reinforce this right here. Okay? So I'm not going to ask you to do 0 or double 0 on the test. So don't think that much into it. Take that thinking on 0 and double 0 and do this. Put it right here. Just like, okay, let me ask you this. What would you win more money off of in Vegas? Pulling a face card or pulling a heart?
Heart.
Well, think about this.
Oh, face card.
Face card, why?
Been there.
Okay, there's less of them. Okay? Think about it. Okay? I'm sorry. A king. I keep doing that. All right? What's the probability of pulling a king?
11.
4 out of what?
4 out of 52.
Okay? What's the probability of a heart?
4 out of 52. It's a what?
13 out of
Oh, low.
52.
That's the face card. I'm tripping. I ain't played cards.
Now, you brought up something, Miss Robinson. A lot of people don't know their deck of cards. All right? If you want to fail this test, you just keep not knowing your deck of cards, because it's going to ask you questions. Homework and test will ask you questions about the deck of cards. Now, an easy way to remember that and you can go to the internet, and I do this because I like trivia and I like little nostalgic things. Pull up Soldier's Prayer or Soldier's Bible deck of cards. Now, I'm not trying to convert anybody, okay? Let me go ahead and say that right now. I have to say that because somebody will call the ACLU. But Soldier's Deck of Cards, it's there it is, I think. Yeah. You have to read that. I mean, you don't have to read it, but when I see the ace, I'm reminded that there's only, one God. It stands for one. And when you see the suits, there's four suits. You just have to read that, okay? It's a little way to remember the deck of cards. If you're scared you're going to get converted because it says Bible, then go over here, and there's another way to learn a deck of cards, okay? You need to know that there's 13 in each suit. I don't know what happened. I thought let me get out of that. There's 13 of each suit. There's 3 face cards in each suit. The ace can be a 1 or a what? 11. It's the only one that has 2 numbers. It depends on what game you're playing, 1 or 11. And then you this is a good
thing to keep.
It's a good thing to to print out. Now remember, you have to hit like 2 buttons. You have to do this, and you have to save picture as, and you have to save it, and then you have to print it out. So that's 3 buttons you have to print, and the printer has to do all that work. So there's a lot of work involved in printing this out, but most of you can do it if you suck at, a deck of cards. Okay? And there's more you could, right here you can view more. And there's plenty of pictures of a deck of cards. Capiche? And that's probably about the only thing that I would suggest that you learn if you suck at it. Because most of y'all know what a coin looks like. Okay? Most of you know what a die looks like. So, let's do a die. Alright? What would you win more money off of? Rolling a 6 or rolling an even number?
No, it's 6.
6. Why?
There's only one 6.
There's only one 6 versus 3 what? Evens. So if the probability is high, you're going to take what? You're going to take less money home. If the probability is low, you're going to take more money home. So the smaller number takes more money home. The 6 versus 3. You see what I'm saying? 6 is only 1. There's only one 6. So that'd be 1 out of 6, which is equal to 0.17. 3 out of 6, which is even, is equal to 0.5. So the lower number, the lower probability, means more what? More money. And that's one of the things you have to remember. What about the let's do this. You go to the racetrack. The racetrack, you got 7 horses. And the first horse is named Secretariat. She was one of the best horses ever. I'm not going to spell Secretariat. But her chances of winning are 20 to 1. And then you got several other horses. Ding, 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 ding. And then down here, you got number 7, Loser's Lariat. And Loser's Lariat is 75 to 1. You got $5,000 in your pocket. And when the mortgage of your house comes due next month, and if you don't pay it, they're going to take your house, and the mortgage, you owe like $75,000. Which horse you going to bet on?
One? Yeah.
Number 7, because you win more money.
But it's gonna cost. He's gonna lose. Exactly.
Well, who knows? Who knows? Is it? That's just statistics saying he's going to lose.
Ah.
You need the money. Okay. Now people say, well, if you win if you take 5,000, bet it on the first one, you're guaranteed. You're not guaranteed anything. The horse can break his leg and fall down. Okay. But which one are you going to win more money? Let me rephrase the question. Which one are you going to win more money?
7.
Number 7, because 20 times 5,000 is going to be 10, and then add another 0. 1, 2, 3, 100,000. But what about 75? 75 times 5,000, that's a BA number. That's going to be a whole lot bigger. So it all depends on how much money you owe on which one you're going to bet. See what I'm saying?
Yeah. What if everybody betted on the first? So they have to split it 100,000 amongst everyone?
No, it's just whatever. See, that's why they put the things here, because not everybody's going to bet on this one because it's guaranteed to win.
Okay.
And that's why a lot of people bet on the last 3 horses. Money. Because the whole purpose of going to the track is to win what? Win money. Well, what are you going to do? Win $20 or win $2,000? What do you want to do to win $2,000? Okay? So that takes care of probability. That takes care of odds in favor and odds against. And it also takes care of payoff. And that's pretty much what should be in 7.1 or 7A. This is the only book I've ever seen that calls their section letters. Okay? So make sure that in any of the homework questions that you can do these 3 things. That is the first section. This is intro. This right here is what we call intro to probability.
7.8.
Okay. Now a little bit of, I think 7B and whatever, the next sections are going to be the additive law and the multiplicative law. I'm going to go back to the handy dandy book and look at, I'm looking for something. We'll do probability distributions after we do probability. I'm not going to do that right now. There's the odds. There you go right there. Odds for is the probability of success over the probability of failure. Odds against is the probability of failure over the probability of success. The reason they have it like this is because y'all ain't got sense enough to know what failure and success is. So they put it like this. Okay? So that takes care of all the way, 7A. I thought 7A included all of those things. And if you look, it says, at a horse race, the odds on blue moon are given as 7-2. If you bet $10 and blue moon wins, how much will you gain? Well, somebody take 7 and divide it by 2.
$3.5.
And multiply by that by 10.
35.
You what?
35.
Now, this is a question that I disagree with on some of these questions. They ask you, how much will you gain? And in my opinion, you won $25. Yes or no? How much did you have to bet?
You too.
10, right? You won 35. So what did you gain? 25. Sometimes they don't say that. They say that you gain $35, and I don't agree with that. All right? So you take that up with the book, but as long as you know what the difference is fine. I think they are saying that once you give that $10 up, it is not yours anymore. That's what they're saying. And they give you $35 when you give them the ticket because you won, so your gain is $35. But some of us would look at it as a gain of $25. You see what I'm saying? Yes, no, maybe.
Yeah, we should get an analytical analysis credit for this class.
Yeah, exactly. The book sucks. Yeah. I don't like this book, and y'all know that, so that's why I'm very lenient with some of the questions, especially on the test. All right, that's 7A. I want to look at 7B because that's where we're going to get into the additive law and the multiplicative law, probably. Will you quit
yawning?
That's very rude.
Can't help it. I'm tired.
I'm human.
My brain ain't got enough oxygen or something.
Oh, is that what it is?
That's what that means, ain't it? Or something like that.
Yeah, something like that. All right, and probabilities. Write down the word and because that's when we're going to talk about the additive law, okay, or the multiplicative law. I get them mixed up. Excuse me. I'm the master of this universe. Thank you very much. I can do what I want to in here. Two events are independent if the occurrence of one event does not affect the probability of another event. They do everything in the world to make this difficult. The and probability and A and B both occur. P and is multiplicative. So I want you to, and this is 7B, I'm going to write it out for you. The multiplicative law. I'm going to turn your book into something you can understand. The multiplicative law.
You need to put your thing on.
Oh, I'm sorry. There we go. The multiplicative law basically is revolved around the word and. What is the probability of you pulling a 4 and a 6? Okay? In other words, the question will end saying blah, 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 and then at the end it'll say, what is the probability of doing this and this? That's what it's going to say. And when you see that word and, that means you're going to use the multiplicative law. Now, with the multiplicative law, there's a question that you need to ask yourself. With replacement, or without replacement? Okay, before I go on, I'm going to go back to basic probability. We're going to come back to that page. We'll go to basic probability, and I'm going to I'm going to draw you a picture of a marble bag. Not Marlboro, marble. Okay, so here's a bag. And for those of you that know anything about marbles, you used to carry marbles in a bag. All right? I never did have marbles because I came up after marbles. Marbles were popular back when the little rascals were running around, I think, 40s and 50s. I don't know. But anyway, in this bag, there is 7 blue marbles, 8 red marbles, 5 yellow marbles, and 6 green marbles. All right? Now, the question is going to say, what is the probability of pulling a blue marble first and second time? It'll say something like that. All right? And it'll say with replacement. Now, what does that mean? Well,
since you put it back.
In other words, when you pick a marble, you don't put it in your pocket. You put it back in the bag after you write it down. That's what it means. Okay, now, if you put the marble back, then it does not affect future statistics or future probability. Say probability.
You said with replacement.
Okay. It does not affect, with replacement, does not affect future probability. So you need to write that down because the book calls it dependent and independent, and I don't know which one's which. I don't use dependent and independent. I use with replacement and without replacement because students can grab onto that a whole lot better than dependent and independent. All right? So I use with replacement or without replacement. So we're going to pick 2 marbles out of this, and each time we pick them, we're going to put them back in. So they want to know the probability of a blue marble. So that's going to be the probability of 7 out of, we got to have the total, so let's do the total. Let's see, 8 and 2 is 10, that's 13, that's 26. Y'all check me. So, the probability of the first draw and the second draw being blue is equal to 7 out of 26 times 7 out of 26. Or 7 out of 26 raised to the what?
Second power.
Second power. Now take your handy dandy calculator, and that's going to be 49 over some BA number, okay? And then take that, and somebody tell me what the decimal is with 49 over 700 something. What is it? Point what?
0.0725.
0.0725. Everybody got that? So what is the probability of you picking 2 marbles and them being both blue? 7%. So would you bet $100 on that? Well, if you wanted to make a lot of money, yes. If you wanted to lose that $100, then no, you wouldn't, because the probability is low. Therefore, the payoff is what? High. Okay.
Does this say 0.72? Oh, thanks.
What?
Thank you.
What? I didn't hear you.
I couldn't see it. Just when you moved it up, I could see it.
Okay. So there's a 7% chance that you're going to pick 2 blue marbles, one right after the other. 7.25%, or a 0.0725 probability. Now, do the same problem, and this time without replacement. So let's take our handy dandy. I'm just going to fold it, if y'all don't mind. And we want to pick, what is the probability of picking the first draw of blue and the second draw of blue without replacement. So what are you going to do with the marble after you draw it? You'll put it in your pocket. And since you're not putting the marble back in the bag, it changes the what?
The total.
It changes future probabilities. And you'll see that in just a second. So the first draw is going to be 7 out of 26. Everybody with me? What's the second draw going to be?
7 out of 20. No, 6 out of 25.
Good. Because you put 1 in your pocket. Oh my gosh. Miss Bradley, that was really weird.
She was mad.
What happened?
She, I don't know if it's the whatever, but you ever seen those scary movies where somebody's head goes, it just goes back and forth? That just happened to you, Miss Bradley. Your head just went.
Well, maybe that was a real thing, and you need to get
Maybe you're possessed. Maybe that's it. All right, so 7 over 26 times 6 over 25. Somebody multiply that out. What do you get? Give me a decimal. Give me 4 places.
0.0646.
0.0646. Everybody get that? What happened? The probability went what?
Down.
Went down. So it's even more of a different. If you take one of the marbles out and put it in your pocket, then it's going to change the probability dramatically for the next one. And that's what they're saying. When you do without replacement, it's going to change this one right here. This is your future probability right here because it comes after what? It comes after this one. This is the present. This is the what? Future. So when you don't put the marble back in the bag, it changes this next one. Now, need to write a note on this. When you're dealing with without replacement, and we can go back to here. When you're dealing with and without replacement, it's not really going to matter. It doesn't really matter after 3 digits. What in the heck does that mean, Hubert? Well, I'm going to give you a problem that you might see on a test. I don't know if they have it in this book, but I use it in my 120 a good bit. Okay? And that's the CDs. Okay? The CDs. Okay? This is a quality assurance type problem. They'll say something to the effect, you work in a company and you work in the quality assurance department and you are trying to find defective CDs in the manufacturing before they go out, blah, blah, blah. These are CDs that you record on, like save files on. They're blank CDs and they're checking to see if it's bad. Either you can't record on it or it's broke or got a scratch on it or something like that. And they say that a batch of 5,400 CDs have come to your office. In other words, like a pallet with a box full of them. Okay? And by past surveys, you know that 20% are going to be bad. Okay? You're going to pick 5 CDs out of that box. If all of them are bad, then you're going to send the box back and have it fixed. Evidently there's a problem in the factory. Okay? Now this is without replacement. Okay? Because you're not going to put, if you're in a quality assurance position, you're not going to pick a CD and put it back. Okay? The whole point for you to pick those CDs is take them to your office and what? Test them. All right? So you're not going to pick it and put it back. All right? So most of these quality assurance questions will be without replacement, but it's not going to matter because how many digits am I talking about here? There's 4 digits there. And I'm going to show you that after 3 digits, like after 300 and something, you don't have to worry about which method. Okay? So, first of all, I'm going to draw a box. And it's a big box. That represents the crate that holds these CDs. There's 5,400 CDs in the box. Everybody got that? Mm-hmm. Good CDs and bad CDs. How many are bad? That's given in the question. What is 20% of 5,400? Somebody take 0.2 and multiply it by 5,400. What do you get?
1080.
I'm sorry, what?
1080.
1080. And subtract 1080 from 5,400.
4320.
4320. Okay, so how did I get 1080? I multiplied 0.20 or 20% of 5,400.
Can you move your sheet up just?
I'm sorry.
You're fine.
There.
54.
Hold on.
Damn, that's even better.
I know.
Yeah.
I'm amazing. Okay, so 5,400, and then I subtracted the 1080 from the 5,400, so that's 5,400 minus 1080, and that gave me that number right there. Okay, everybody see that? Okay, now the question says, what is the probability of picking 5 CDs and all of them are bad without replacement? So then you go to the next page. And I'm going to redraw the box. 5,400. Good is 4320. And bad is 1080. So I got to pick 5 without replacement. So 1, 2, 3, 4, 5. Well, the first one's going to be 1080 out of what? 5,400. I put that CD in my pocket. What's the next one going to be?
1079.
Over.
53.99. Yeah.
Good. Now put that one in my pocket. What's the next one?
1078.
Over.
53.98.
And so on. Get your handy dandy calculators out and start calculating. I'm going to let y'all work on that for a second because it's going to take you a few minutes to actually do it. Good gracious. That's the only thing I hate, Butterfingers.
They fall apart.
They fall apart. Dang old Butterfinger all over the dang old screen. Miss Bradley, you are looking all Annabelle-ish. Every time you move, it must be your what do you call it? Wi-Fi. Now we know how they make scary movies. Don't be that way, Miss Bradley. She took her video off.
No, she did.
Yeah, she don't want to be dang old.
Look at me. I don't want to be seen because I look.
No, you're. I can't describe it.
Yours is doing it too. When I look at, I look at your face right here, but when I'm looking at your screen, it's like it's pixelating and then it goes clear.
I think it's your internet.
No, my Wi-Fi is amazing.
Okay, well nobody else is doing it except for you. So it must be your. I tell you what, it's your computer. That's what it is.
Hubert, this chapter is hard, huh?
What?
I don't know if anybody else thinks that but me, but I'm doing the homework right now, and
Well, you got to give me time to go over it first.
If I didn't have you an example, I wouldn't know how to do none of this stuff.
Well, just mark it up as me being fantastic. Okay. So, what do you get? Give me like six digits.
I'm still going. I got those. I got a number, but I'm not sure if it's right.
Well, give it to me and we'll put it out there.
It says 3.1.
No, it's not going to be 3.
Well, it's negative exponent. It says.
Okay, what does it say?
I got the negative 4 exponent.
3.4
yeah,
times 10 to the what? Negative what?
What'd you?
You said 3.4.
No, I got 3.1763 to the negative.
3.1763 times 10 to the what?
Negative 4.
Negative 4. 3.1763. 1, 2,
Well,
3, 4.
it's kind of that. Yeah, I got that point.
0.0031763. Is that what y'all got?
I got 0.00317.
Okay. What did y'all do it? What did y'all get? Got 2 people here at Anderson campus that's participating in class.
I got
that number.
the same thing as you did, or the same thing that you drew.
Okay, good. All right. So that means that we've got 0.0031763, which is 0%. Okay? So there's a 0% chance that you're going to pull 5 discs and they all be what?
Bad.
Bad. Now I want you to do it with replacement. See what you get. With replacement is real easy. You do 1080 over 5400 raised to the what? 5th power. This is with replacement. Now, somebody give me several digits on this one.
0.00032.
5450.
0.0032.
000. 3 zeros.
Okay, well, y'all gave me the wrong zeros over here because I got another 0. Okay, I'm sorry. There we go. All right, now look at the 2 answers.
I need a calculator.
0.00032. What is this one? 0.00032. Is there a difference between the 2?
Not really.
No. So what am I trying to tell y'all as students? What am I trying to tell y'all?
After the 4 digits don't matter.
After 3 digits, I usually tell students the 300s. 300s and above, doesn't matter which way you do it.
So so you're saying basically if it was without replacement, you can still do it like the
It doesn't matter. You're going to get the same answer.
Got you.
Because they're going to ask you to round to 4 digits. And if you round this answer to 4 digits, tell me what you're going to get. 0.000 what? And what are you going to get if you round this one to 4 digits?
Same thing.
You're going to get the same thing.
Put them notes back up there.
Now, just be careful. Which one? This one?
Yeah.
That one?
Yeah.
Just be careful. You have to try both of them until you start to feel comfortable I usually tell students above 300. That's what I usually tell students. Because below 300, that fourth digit is different. Okay? So if I give you a problem and I say, well, there's 300 or 250 CDs and 100 are usually considered bad. What is the probability of picking 3 CDs without replacement and them being bad? Now, would you do it either way on this one? I wouldn't. Why? Because that fourth digit is going to be different. Okay? Here you got 250, 100 bad, that means 150 are what? 150 are good and 100 are what? Bad. Without replacement means that you're not going to put them back. So that's going to be 100 over 250 times 99 over 249 over 98 times 248. Now, if you did this one, then you get a number here, and you did 100 over 250 raised to the what?
Second.
Third power. You're going to get 2 different answers that's not going to come out to be the same. Why? Because you're dealing with a 3-digit number less than what?
300.
Less than 300.
So
you see what I'm saying?
So you're saying if it's 500, you can
500's okay, yeah. Somebody take 100 over 250 and multiply it, raise it to the third power. What do you get?
.0640.
0.0640. Did everybody get that? All right, now do this one right here. Do 100 over 250 times 99 over 249 times 98 over 248 and see what you get. Somebody tell me what you got.
I got 0.0628.
0.0628. Is there a difference?
Yeah.
Yes. You see why there's a difference? If I said round to 3 digits, you'd have 0.063 versus 0.064. Does everybody see now where to do, you got to do both? I mean, you can't do either. Below 300, I wouldn't take a chance. Okay? Fish, question? Now that's the multiplicative law. I gave you like 3 examples there. The marbles, the CDs. I gave you 2 examples of the CDs. Now let me show you the additive law. The additive law is with the word or. What is the probability of picking a blue marble or a red marble? Okay. Now, you don't have to worry about replacement with these guys. What you have to worry about here is always subtract the overlap. Always subtract the overlap. Usually these guys are going to be given tables. And I would highly suggest in this section you use highlighters. Kind of helps to use highlighters in this section. And the third thing I'm going to tell you is don't overthink. Don't overthink the tables. I've been teaching Math 120 and Math 103 for a while, and when I do this section, I always tell people don't overthink the tables, because what students do is they try to make sense out of the tables. Do not try to make sense out of the tables unless you want to confuse yourself. Okay? Just look at the tables and use the highlighters. Let me give you a prime example of one that you're going to see with the additive law. You're going to be given a table. And this table is going to be broken up into sections. And here I have RH negative. Here I have RH positive.
Now you're talking my language.
What'd you say?
So now you're talking my language.
Yeah, but I have no idea what. I think this is blood types, isn't it? And it's A.
Antigens in your blood.
Yeah.
Feels pregnancy.
Is it A, O, B, and AB?
Yeah.
I think that's right. And I'm going to put 3 here, 4 here, 5 here, 2 here, 5 here, 6 here, 3 here, and 1 here. Now I want you to find the probability of pulling an A or a B. Now, some of you may know how to do this, and that's fine, but some of you may not have a clue. If you don't have a clue, just sit there and meditate. Om, malaka, Om. First thing you got to do is find the total. So when you do one of these, the first thing you want to know is the total. I don't have highlighters, dang it. I need to go get some. Y'all got some highlighters? Might have to borrow y'all's.
I got a blue one and a yellow.
That's fine. I don't need it right now, but the total, well, there's 10, there's 10, 20, 26, 29. Is that what y'all get?
Yeah.
So that's the first thing. So I'm going to draw a fraction, and I'm going to put 29 on the bottom. Everybody with me? Now, hand me those highlighters, Miss Smith. Thank you. Take your highlighters and highlight what you're trying to find. A and B. And then I'm going to put the A section right in here. And the yellow section right in here. And the overlap goes at the end. Minus the overlap. So, 3 plus 5 plus, because it's the additive law, so that plus is right there. 5 plus 3. Is there anything overlapping? Is the yellow overlapping with the blue? Yes or no?
What do you mean by overlap? Yeah.
Do they overlap? Do they touch each other? Does the blue touch the yellow?
No.
No, so it's 0. If they don't touch, the overlap is 0.
Like they literally touch.
They don't touch each other.
I'm just saying if it was an overlap, I'm just saying.
You're gonna see that in just a minute.
Okay. Yeah, cause I'm.
Can I be in charge for a while?
I know. I'm like.
Can I be in charge for a while?
Yes.
Okay, I appreciate it. Wait a minute. All right. So I get probability of A or B equals 8 plus 8 minus 0 over 29, which is 16 over 29. And of course you change that into a decimal.
So it's 8 plus 6.
All right, let that sink in because this is one type of problem. There's like 15 problems you can do with just this one table. This is one problem. Okay, who has R2D2 in the room?
Not cheaper.
Sorry.
That's all right, I'm just kidding. All right, now I'm going to draw the same, I'm just going to fold it. I'm doing that, I'm folding it because I want you to see that it's the same problem. I'm just going to put it on top of this next page. Okay? Now I want you to find the probability. No, I need to redraw it. So I'm going to redraw it. Three, 4, 5, 2. 5, 6, 3, 1. I want you to find the probability of A or RH negative. Oops. RH negative. Again, you're going to take your handy dandy total, put it on the bottom. And take your handy dandy highlighter, and your A is going to be in blue, and your yellow is going to be RH negative. Uh-oh, what do we have?
Oh.
We have an overlap. So now I'm going to rewrite it. I'm going to do my problem. I'm going to do the blue. 3 plus 5 plus 3 plus 4 plus 5 plus 2 minus the overlap. What's the overlap?
3.
3.
Okay. I like this stuff.
That Z-score stuff.
No, I don't.
Could've kept
That one
that.
was all right. I'm talking about the last stuff we just went over, all that P and give it to me in the chart.
Just quit.
Right.
So the probability of A or RH negative is equal to 8 plus 3 plus 4 is
8,
5 plus
9.
5 is 10, that's 14. Minus 3 over 29 is equal to 22 minus 3 over 29, which is equal to 22 minus 3, isn't that 19?
Yeah.
Over 29, which is equal to what? Point what?
552.
Everybody get 6552?
Yes.
And that's how you do the additive law. Now the reason I do the overlap like I do, because there's always somebody that thinks, well, why don't you just cancel the 3s? I've tried teaching it that way, and it don't work. This is the best way to teach it, because the students actually see the overlap and they subtract it. Every single time they subtract it. Wherever those 2 inks cross over and they make a green, or see that greenish color right there? It is kind of greenish, isn't it? It goes to the 3 right there. That's why highlighters are so important in this section. You actually see the overlap. That greenish area, you've got to subtract it. If I had a green highlighter, I would highlight that 3 right there green, but I don't. So, and that's the best way to show the additive law. I don't even want to know how the book shows it, because I've seen the other book, the 120 book, it doesn't show it much better. So, who's got a question on that? You mean I taught y'all so well that y'all don't have any questions?
That one was pretty, yeah, that one's probably self-explanatory. That one.
Okay. What about you, Miss Bradley? I want to call you Miss Roberts, and then I want to call you Miss Grant, and I just get confused.
Let's just stick with Miss.
Miss what?
I've been called a lot worse.
Miss Grant.
Yeah,
Well, I just did the homework, and I sent you some questions. So Wednesday I'll be, or next, no, what's today? So Monday I'll be in class, and hopefully
Well, that's
you'll
fine.
go over the questions.
And that way everybody else can see the questions on the homework too. That's good.
Yeah. I'm
All right.
a little bit confused. That's all right.
That's all right. What happened
That's
to
all
Zach? He just took off. Zach, you there?
There was
I'm
a
here.
fire drill.
We had a fire drill.
Oh Lord.
Sure you did.
During Zach's microphone, it's not turning around. Zach, I don't know why.
We
All
had a. Can you hear me?
Yeah, I can hear you, but it doesn't look like the camera's turning around to you, so I don't know what's up with that. But anyway, y'all go ahead and have a good weekend. I'm going to shut her down. Well, I'm going to shut down the recording. If you have any questions, you're welcome to holler at me.